We're starting section 15.1, functions of two or more variables. And first we discussed the domain and range, then graphs, then level curves and contour maps. So a function of two variable f, a function of two variables, is a rule that assigns to each ordered pair x and y in a set D, which is domain, a unique number f of x and y. So each f of x and y, that it's going to be assigned to f of x and y or z. D is called the domain of f. The range of f is the set of all output values of f for points in D. Range of f is basically f of x and y, the output of f of x and y, as x and where x and y belongs to the D, which is the domain. The domain is a subset of R2. And the range is a subset of R, again, functions of two variables. These are the scalar output functions. We write z equal to f of x and y for pairs x and y in D. X and y are independent variables of f. Z is the dependent variable of f. So if you're comparing to calculus of one variable, this is going to be, there we had y is equal to f of x. Now you're getting z equal to f of x and y. So the input here is x and y, and z is the output. Their input was x, output was y. Functions of two variables. Example 1, find the domain and range of the function z equal to f of x and y, where f of x and y is square root of x squared plus y squared minus 1. So how do we find this? Remember, this is a composition of basically square root and something that is inside. When does square root, where is the domain of square root? For all the values that are inside of the square root are positive or equal to 0. So that's what you said. What is inside square root? X squared plus y squared minus 1. And this has to be bigger than equal to 0 to give the domain. That is x squared plus y squared is bigger than equal to 1. Oh, this seems very familiar. If I switch the bigger than equal to equal to, I get the circle of radius 1. This is -1, this is 1, 1, -1. And so that we're saying that everything outside this circle and on the circle, outside the disk and on the circle. Nicer picture looks like that, and the disk is empty. The boundaries are included, and everything outside the disk is included. Now, what is value output of any square root function? Square root functions can give only bigger than equal to 0 output. This is why the range of this function is going to be 0 and infinity. And then, of course, considering that inside the function can be as low as 0. The output is going to be 0 and infinity. And inside function can be as low as you want, positive value, outside function, and as high as you want, as infinity as positive infinity. So the output of square root is going to be 0 and infinity. The next question is find the domain and range of the function z equal to f of x and y. 1 over x plus y minus 1 is the rule of the function. So this is again a composition of two functions. The outer function is 1 over the scalar x plus y minus 1. And so basically it's just the outer function in this case and the previous case were both functions of one variable, and inner functions were functions of two variables. But the outer function and the functions of one variable, I know what the domain and what the range is. For 1 over a variable, that variable that is in the denominator should not be equal to 0. So I set that not equal to 0. And what I end up with is we have to exclude the line x plus y equal to 1. So if you find that line, which is this line over here, and you exclude it, everything else, sorry, it's supposed to be another color, everything else is going to be inside the domain. Now, how do I find the range of this function? Range of function is again because the denominator can be as low as you want, non-zero, and it could be pretty much anything except for 0. And the range is the same range as function 1 over x, which is negative infinity to 0 and 0 to infinity not included. So again, this is a better picture because you can see that the line x plus y equal to 1 has been removed and everything else is the domain. And the range, as we spoke, is negative infinity to 0 and 0 to infinity. Now, example 3, find the domain and range of the function z equal to f of x and y equal to natural log of y minus x squared. Again, in here, there's an outer function that is a single variable function. The composition, outer one, is a single variable function. Natural log only takes values that are strictly bigger than 0. So the domain of the entire function, since outer one only takes inside of it has to be bigger than 0, the domain of the entire function has to be, y bigger than x squared. How do I find that? Draw y equal to x squared, and then everything above that is going to be the domain. So what is the range? Again, because the inside can be in anything bigger than 0, the range is the same as range of natural log, which is again negative infinity to infinity. So this is a domain and the range is negative infinity to infinity. If you notice here, the boundary is dashed. That means it's not part of the domain because y equal to x squared is not going to be part of the domain. Graphing two variable functions. The graph of a function z equal to f of x and y with the domain D is a set of points x, y, z such that z is equal to f of x and y is in the domain. So for example, here the domain is this blue area down, light blue area down here. The graph is colorful area above that, and so for every point x, y in the domain, and since I'm in 3-dimensional, I'll put a 0 in here also. I can find a z-value for f of x and y. And so basically, if I go from x and y and 0 all the way to that z-value, I get a point that represents z equal to f of x and y, basically. And that's how we graph the function for every x and y in the domain. We find a z-value, and from that x and y, we go up z steps, and the height of z steps, and we get a point on the graph. Graph of a few functions that we just discussed. We discussed all of these functions. For example, we discussed that square root of x squared plus y squared minus 1 has a hole, and the entire unit circle was empty in there. And so that if you look at this picture, the domain does not include that unit circle. It looks like a ball without a bottom. And then the other thing that you notice, only z values are positive because the output of the function is always positive, equal to 0. And here you notice that there are two, it's sort of like analogous to one variable graph of f of x equal to 1 over x. You can see that there are two sheets, one goes up, one goes down. It's sort of, instead of having asymptotes that are lines, there are asymptotes that are plane. And so the domain is missing the line x plus y equal to 1. And the z values are also missing z equal to 0, basically. And over here also natural log, it sort of looks like if you take the upper part, the intersection of the graph with, or cross section of the graph with x equal to 0, you get the graph of natural log of y, basically. And that's something to consider. It's just it's not that far from it all relies on the knowledge of calculus 1 to understand how the graph looks like in calculus 3.